So yeah, I'll read. It says, extreme and relentless heat in the Arctic has resulted in a shocking lack of Arctic sea ice this year. The refreeze season is millions of square kilometers behind where it should be, orange line, where we are in uncharted territory right now. This is the daily coverage since April. And then you can see the GIF is going through the year so far, starting in April, and what's happening with the sea ice. So take it away, Jim. What's going on?
What's going on is they're losing sea ice. But if the one thing I really wanted to point out, which was not mentioned here, is that if you look at the animation, especially get to the later time period, or more recent, I should say, you notice how you're seeing more and more gray appear in where the ice is.
Right, yeah. What's going on?
That's a reflection of loss of multi-year sea ice.
Oh my goodness.
So the ice is not as thick, it doesn't persist as long. Because when you have multi-year sea ice, 5, 6 years, whatever, it's when the satellite looks down on it, it's extremely white because all that albedo, all that being reflected off. But when you start getting into first year ice or ice just forming, there's still a bit of translucence to it. It's not complete. The albedo is not very high, so it's going to reflect back up to the satellites. The satellites will quote unquote see it as gray. So what we're seeing here, we're
Wow.
seeing less and less multi-year sea ice. That's what this is showing. And if you think back to how we discussed with all that Zach has presented with the volume, not just only the extent in square kilometers lessening, but the volume is lessening. The lessening volume is reflective of loss of the multi-year sea ice. And this animation shows it very well, especially when you go towards the Alaskan, the East Siberian seaside. You see more and more of the gray creeping in.
Which again is just alarming, the rate of which the multi sea ice is shrinking. And like you said, the volume is another issue. So not only is there lack of sea ice, the sea ice that is there is shrinking in size.
Exactly. And if you
So
also look at the animation, you see that, I guess it's yellow line that kind of rims around the Arctic basin there.
right.
That's the median ice extent for that time period in the
Oh
graph.
my goodness. Holy
That shows you how much ice has been lost from the average.
wow, Jim. There's so much to say on that because we've talked about, yeah, the median and then how it's going to change in the 30 years, but just, oh my, okay.
So in other words,
That's,
we see the blue, the space between the white and the yellow line, that blue there. Basically, that should be filled in with ice. Keep in mind that when January 1, 2021 rolls around, the new 30-year median will be 91 to 2020.
and real quick, what does that do? I mean, it just doesn't make it less dramatic, but there's still records being broken. I mean,
What it does is it's a moving average.
okay.
And does it make it less dramatic? In a way, yes, it does. But it's what the atmospheric folks do. They do this 30-year moving average. There's nothing saying you can't go back and say, okay, now let's look at the past 40 years. Let's compare it to the
Right,
past
okay.
50 years. The thing is, when you shorten the time span, and especially looking in the data, it does allow to whoever's doing the analysis to pick up on any nuances that may be appearing. If you want the big picture, sure, go back 100 years, go back
Right.
50 years, that kind of stuff. But if you're looking for nuances, then you usually limit your time span. What you do is you see the pattern, it goes up and down, up and down. Well, that's the seasonal aspect of it. So it's
Okay.
reflecting the seasonality. But the overall trend, when you look at that, if you were to fit a regression function through that, you have positive slope.
Positive
So
slope.
so showing a warming, and then when you're plotting the sea ice, you're going to have negative slope showing the decrease in the sea ice.
So interesting. And sad because we know the consequences of that, the neo-Arctic, as you called it, which is the new Arctic, which might not even be the Arctic. And we've talked
Yeah.
about long term what could happen. We could get to climate scene in the Devonian, even hotter than that. I mean, these are ancient climates, but where the Arctic is like having palm trees kind of situation. I mean, is that not in our lifetime, but in the direction of that, right? Like that's the
Well,
consequence.
see, again, you have to keep in mind, like you mentioned, the Devonian. Okay, yes, the planet was a lot warmer back then, but where were the continents located?
True. Okay. You're right.
You had open in the polar regions. You had open waters.
Okay.
Well, for the reasons we're seeing today, why the Arctic is so much warmer, you have open waters. It absorbs the heat energy and hangs onto it. That's the reason why the Devonian, and if you want to go more recent with the Paleocene, Eocene
Right.
thermal max, okay, the polar regions were water. Water absorbs a lot of heat energy. It gives off that heat energy to keep things warmer and if not hotter. So what we're seeing here, especially with the Arctic being warm and we're having warm winters and all that kind of stuff, is kind of a reflection, although probably not as severe or as dramatic as back in the Devonian, of the situation when you have open polar waters. And don't forget, back then, even Antarctica was not at the bottom of the planet.
Right.
Antarctica was like somewhere in the subtemperate latitudes. So back in the Devonian, both polar regions were open water.
Okay. So it's hard to compare. So I know I always, as a historian, I want to compare to the past, but it's not, you can, but you always have to have that asterisk. But
That's right.
yeah,
You have to keep in mind, and this is something I don't see a lot of in the analyses, is taken into account plate tectonics, basically. Now, granted, if you're
interesting.
only going back 50, 60 million years, okay, the continents were pretty much in the same positions that they are now. There's some slight differences, but so okay, it's not maybe necessary, but the Isthmus of Panama wasn't up. It wasn't in place 50, 60 million years ago.
Mm-mm.
And you go a little further back and say 80 million years ago, you had a big sea, splitting North America in two.
So it's the climate and the, like, you're right, the plate tectonic issue. Where is the land mass and how does that contribute to different climates and such, different species, things die out and evolve because we're always changing on the planet. But our current time period is the human activity issue. What has humans done and what's going on in the Arctic is a big example of the rapid change.
Yeah. Yeah, and don't forget, when you have the continents in different positions, the ocean currents, ocean
Right.
circulations are going to be different, which means how the heat gets distributed will be different.
So
And
interesting. God.
so that opens up a whole other avenue of analyses and so forth.
Well, we can look at the next graph, just what's going on with the Arctic. It's still Scott from Scotland. Okay. He says, while large parts of the Arctic remain ice-free, temperatures remain extremely high compared to normal for this time of year. Temperature is unable to drop much below freezing where open water remains. In the past, ice cover would allow temperatures to be more like negative 25 degrees Celsius. Wow. So what's going on with these two?
And as you can see, let's look at the one on the right first. With we see the ice in the ocean. You see
Okay.
the yellow dash line there. Hey, what does he have in there? Missing ice.
Oh God, I know it's so serious. It's an issue. It's yeah.
But
So
no,
the
but think back to the GIF we just looked at. That it's reflecting the same thing. Having that missing ice where the looking at the median, that's where we expect to see the ice, and it's not there. Well, take a look at the one on the left now. You see how much hotter that is? Not only on the Siberian
oh
landmass,
my
but in the ocean itself. So
oh
you have all that heat energy that the ocean has absorbed, specific heat of water, it's going to slowly cool down. So in other words, this open water is going to persist for quite some time.
I remember you said last time the blue ocean events are coming sooner than later.
They're now saying 2022, 2024, somewhere in that time period. They anticipate at least a couple of months where there's 0 square kilometers of sea ice in the Arctic Ocean. Not just, less than 1 million square kilometers, and it's okay, it's ice free. No, it's basically like 0. It's like you can take a dip at the North Pole, go swimming at the North Pole.
Oh my god. I know, but like it's so serious because the Arctic is collapsing, but yeah, you could have a resort there. I mean, that's what's so hard too with like the capitalist mind, right? We can exploit the Arctic now, but
Right?
no, there's so much
That's
more to that issue. But just yeah, just the red in the ocean. We've talked about over the just 2020 in general what's been going on with the temperatures in the Arctic, and they're always like extremely red, air temperature and water temperature. So yeah, this is
it's
just
just it's just the change is so dramatic, and when you really think about it, it's happened extremely quickly. When you think about it, how quickly this came on. Now, granted, you had to build up the levels of the CO2, but it's like you reached a tipping point, a threshold, and phew, everything's gone, whammo. There's a technical term.
everything is going whammo here on planet Earth.